Well, I want to discuss James Watson and Francis Crick, but before I talk about them, because the race is on now to discover the structure of DNA, and before we get started with the two men that did this, I want to talk a little bit about Chargaff's rule. Chargaff's rule is he went and he analyzed DNA, and he found that adenine equals thymine, the base, and guanine equals cytosine, and that the reverse, like for example cytosine and adenine, didn't equal each other, and neither did guanine or thymine. And Chargaff's rules will become important when we're talking about the structure of the DNA that Watson and Crick discovered. And we'll see why this is so important. In fact, it helped Crick and Watson understand the structure of DNA and how to put it together. So that'll become very important. And of course, you probably all know that Watson and Crick were involved in the discovery of DNA, but it involved a lot more than just Watson and Crick. The first thing that I should emphasize is that Rosalind Franklin worked at the University of Cambridge along with Watson and Crick. Watson and Crick were in the famous Cambridge laboratory. The name of that laboratory was the Cavendish Laboratory. Rosalind Franklin was over in Cambridge working for Maurice Wilkins, and Rosalind Franklin was really an expert on X-ray crystallography. And you needed X-ray crystallography in order to understand the structure of DNA. Now, about this time, in the early 1950s, the race was on to find this structure, and Linus Pauling had just published a paper in which he believed that the DNA was a triple helix. Now, Linus Pauling had already won a Nobel Prize in chemistry. He would later win another Nobel Prize in peace, so he won 2 Nobel Prizes. Pretty bright guy. And Watson and Crick knew that Pauling was one of the top chemists in the world. So when they saw his paper, they were disturbed at how close he was getting to discovering the structure of DNA. But one of the things that Watson realized immediately was that it couldn't be a triple helix because of the way that Linus Pauling had set up the phosphate groups. You may remember that the backbone to DNA is made up of sugars and phosphate. And he had those phosphates facing each other. They have negative charges on them. So Watson realized that Linus Pauling was wrong, and that he still had a shot, he and Crick had a shot to beat Linus Pauling to the discovery of the DNA. Well, at the time, Watson knew that Rosalind Franklin was doing the X-ray crystallography, and so he went over to talk to Rosalind Franklin about the potential of working together. And it's not clear what happened, but they had a falling out. Now here are both teams need each other, and yet they can't get along to do this. But something interesting happens when Watson's leaving Franklin's lab, and they've decided they can't work with each other. Maurice Wilkins calls Watson aside, and he says, "Look," he said, "I need to show you this photo that Rosalind Franklin has taken. It's the photo 51 here." And when Watson sees that photo, he recognizes immediately from his knowledge of X-ray crystallography that it is a double helix. That is, the DNA is a double helix because of the superb picture Rosalind Franklin has taken. Now, Rosalind Franklin has already published a paper in which she doesn't believe that the DNA is a helix. She seemed to be very interested in the details of X-ray crystallography and taking superb pictures, but her interpretations of what those pictures meant left a little bit, well, she needed to, I think, pay more attention to this overview also, because she didn't recognize that this photo was a double helix, and Watson did. So you can get into the ethics here, and a lot of people have talked ad nauseum on this, whether Maurice Wilkins should have taken Rosalind Franklin's picture and shown it to Watson. He thought they were all on the same team, so he didn't have any qualms about showing the picture, but of course it was Rosalind Franklin's picture. So there's been a lot of debate as to whether even Watson should have seen that. One thing's for sure though, if Watson hadn't seen that photograph, probably Linus Pauling would have beat them to the discovery of the DNA. So I think that's a little bit of interesting history. And of course then Watson, after seeing this photograph, runs back to the lab. He tells Crick, and they're racing now to try to determine how the structure fits together, because they know it's a double helix. And what they start to do is they try to match up the bases, like they take A and they match it to A, and they take T and they match it to T. But that's not working. They do cardboard cutouts and they can't get everything to fit together nicely. So it's a real problem. And then Crick remembers Chargaff's rule, and this is where Chargaff becomes important. And that is that they recognize that A has to go with T and G has to go with C. And once they realize that, then it all starts to fall together, and they recognize that they figured out the structure of DNA, and that it is a double helix with these bases matching up in this way. And so they run off to the lab and they get a shop to make the DNA structure so they can make sure that everything fits in. And you can see here the DNA structure. It's a double helix. It's, as you can see, the twisting there. And notice that it's got a sugar phosphate backbone, which we've talked about before, and then the base pairs. And notice, of course, that E and T match, and so G and C also match all the way down. And of course, immediately Crick and Watson and Crick realize that the entire system can break into half, and each side is preserved as a coding system. And so what they do is, and I think this was very fair to Rosalind Franklin and Maurice Wilkins, they go to them, they tell them that they figured out the structure of DNA. And so what Franklin and Maurice Wilkins do is they publish a paper on the X-ray photography that Franklin has taken, and that's published in Nature. And then Watson and Crick published a paper on the structure of DNA and how it all fits together. And one of the remarkable things in that paper was kind of the understatement of the century. Watson and Crick at the end of the paper make the following statement. I thought it was interesting enough to read. It has not escaped our notice that the specific pairing we have postulated immediately suggests a possible copying mechanism for the genetic material. What I mean by an understatement is, obviously it's clear to anybody that reads the paper that there is a way to code, and that is the way the sequences of the bases set up here. Really, Watson and Crick have discovered the secret of life. Now, to get back to the politics of this a little bit, they did this in 1953, and their paper came out in 1953. And they eventually won the Nobel Prize. Wilkins and Watson and Crick won the Nobel Prize. Rosalind Franklin, it's a sad story. Rosalind Franklin, because she was working with X-rays, and back then they didn't know how serious it was to get too much X-ray radiation. She eventually died of cancer, and they don't give the Nobel Prize posthumously. There's good reason for that. I think the prize is up over $1 million now, and the reason that they give the prize is, well, people can use the money in any way they want, but they're hoping they'll use some of it for further research. And if you're not alive, obviously you can't use it for further research.